Hello viewers, this is Mr. Banda, Mathematics Made Easy. So in this lesson, we are going to look at Cambridge Additional Mathematics. 0606 is our code. And the question is coming from 2023, paper 2 and question 4. The question reads, y is equal to sec squared of 5x minus tan squared 5x over cosec of 5x. We are required to show that y is equal to, this y is equal to a sine bx, where a and b are integers. Having shown that, we should find the integral of y from 0 to pi over 2 with respect to x. So to solve this particular question, we have to make use of identities, the Pythagorean identities. So let us look at how this must be done. So for the working, we have that y is equal to sec squared of 5x minus tan squared of 5x over, we have cosec of 5x. Now, take note that tan squared of 5x, this one gives us, in identities, it gives us sec squared of 5x minus 1. Okay, take note that tan squared of x is going to give us sec squared of x minus 1. So this is one of the Pythagorean identities that we know. So where there is tan squared of 5x, we are going to put sec squared of 5x minus 1. So this is going to be equal to sec squared of 5x, this one we have here, minus, in brackets, we have sec squared of 5x minus 1, going by that identity, divided by, we have cosec of 5x, like that. Now, from here, this is going to give us sec squared of 5x minus negative times sec squared of 5x, it will give us sec squared of 5x. The negative times this negative 1, this will give us positive 1, divided by cosec of 5x. This one right here is going to give us sec squared of 5x minus sec squared of 5x, that will give us 0. So end up having 1 over cosec of 5x. This is going to give us sine of 5x. Not forgetting that cosec means 1 over sine of 5x. So when you have cosec, which means 1 over sine, and you have cosec of 5x, this will mean 1 over sine 5x. So 1 divided by 1 over sine 5x will give you sine 5x. So that's how we have shown. So therefore, y is equal to sine 5x shown. So that's how we show that y is equal to 5x. Hence, let us evaluate this integral. It means that the integral now from 0 to pi over 5, instead of us putting y to be this complicated function here, what we can do is where there is y in this particular integral, we will put sine 5x, because we have shown that the identity of this function is basically sine 5x. So we'll have the integral from 0 to pi over 5 of sine 5x with respect to x. this particular integral can be evaluated using what we call u substitution, where we let u, so we can let u to be equal to 5x. It implies that du, when you differentiate u, you will get 5 dx. This implies that dx is equal to du over 5. You can see that making dx subject of the formula, you have du over 5. So let us substitute. Where there is 5x, let us put u, and where there is dx, we put du over 5. This will give us the integral from 0 up to pi over 5 of sine u times what is dx, we'll put du over 5. So 1 over 5 is a constant here. This will further give us the integral from 0 to pi over 5 of sine u du, that multiplied by 1 over 5. Okay, because dx from here, we have dx being equal to du over 5. So 1 over 5 can come this side. So that we start with it as a constant. And this will further going to give us the integral. So 1 over, okay. So that one will give us 1 over 5, the integral, because this is a constant, so it can be brought outside the integral from 0 up to pi over 5 of sine u with respect to u. Okay. Now, having done that, know that when you differentiate cosine, you get negative of sine. So integrating sine will give us negative of cosine, because integration is a reversal procedure, a reverse procedure of differentiation. So integrating sine u will give us 1 over 5, the negative of cosine u, and we are integrating from 0 to pi over 5. So let us substitute for the value of u. Okay, we know that u is 5x, so that one is basically 1 over 5 negative of cosine 5x from 0 to pi over 5. This will give us, when you substitute pi over 5, we are going to have 1 over 5. Substitute pi over 5, we'll get negative of cosine pi. When you put pi over 5 here, where there's x, you have 5 times pi over 5, which will give you pi. So this value minus, when you put 0 where there's x, you will have negative cosine. This is negative, so negative cosine of 0. And that will give us 1 over 5. Cosine pi gives us negative 1. Cosine pi is negative 1 times this negative will give us positive 1. Minus cosine 0 is positive 1, so it will be negative 1 here, giving us 1 over 5 times 2, which will be equal to 2 over 5. So 2 over 5 is the value of this particular integral. I hope you have enjoyed and followed the lesson. Thank you so much, and please do not forget to subscribe to my YouTube channel, Mathematics Made Easy with Mr. Banda. God bless you. So that's what to give us the moment we evaluate all the values of pi over over 2, wherever there is x in this particular integral, it will give us 2 over 5.